Hi. I'll give you 3 guesses who got me into this mess. Actually, you only need 2. One for the X and one for the P. Can you believe this is a concrete boat? And XP has talked me into being the passenger. He didn't mention I was going to be the only passenger and that this thing doesn't have an engine. See, it's all part of one of his inquiries. It started when he was in the park. There were some children there playing a game. You know, the one where you drop sticks in the water and race them under a bridge.
Where are they? Don't worry, they'll be coming in a minute.
Anyway, XP thought it seemed fun and wanted to try it for himself, but it didn't quite go as he expected.
Activate smart specs.
Activated.
Investigating water. Question, why do some things float and other things sink?
Suggest you experiment with floating and sinking.
But first, to rescue my cosmic screwdriver and my Scandoo. Now, to do some investigating. Right, what shall we start with? Just what I want. Sample 1. Wood. Result, it floats. Sample 2. A pebble. Result, it sank. Now let's try some other things from my pockets. Aha! Sample 3, plasticine. Result, it sinks. Sample 4, a crisp packet. Result, it floats. Sample 5, a cork. Result, it floats. Sample 6, a ruler. Result, it sinks. Let me see. Is there a pattern to all of this? Is it that flat things float? No, the ruler didn't float. That's not right. Maybe it's that wood things float. No, the crisp packet floated too. Maybe it's that round things always sink. No, the pebble and the plasticine sank, but the round cork floated. Oh, it's all very confusing. Time to call Sarah, I think. But first, to get my ruler. Oh, where is he?
I do wish you'd knock sometimes, XP.
Oh, sorry. What are you doing?
Well, I'm weighing myself. So we're doing this lifestyles project thing in school and I was just filling in the chart. How tall do you think I am?
I'll tell you, exactly. 148.6 6244787244664466 centimetres.
Wow, Miss Watson will be impressed with this.
Good. I'm doing an inquiry.
And you want me to help you look it up on the computer?
How did you know that?
Lucky guess. Okay, what are we investigating?
Oh, well, you see...
XP told me what he'd been up to, so he started looking for some information. I said we ought to begin with boats, because we knew they floated. Well, come over here and let's see what we can get on the screen.
Okay.
Okay. Right. BOATS. Choose. History of boats, designing boats, fantastic facts, and famous sailors.
Let's do fantastic facts. It might give me an idea.
Okay.
Boats come in all different shapes and sizes. Here are some fascinating boat facts. This is called an air dinghy. It is partly a boat and partly a hang glider. This is a dragon boat. It is a kind of canoe and comes from Hong Kong. They have races every year at their Dragon Boat Festival. Up to 40 people race in each boat. Some boats don't even float. They skim or hover on a cushion of air. That's why this boat is called a hovercraft. Floating on this cushion of air means that the hovercraft can move on land as well as in the sea. This is the Queen Elizabeth. It was the biggest ocean liner ever built. It weighed 82,998 tons.
Flip.
Why flip XP?
Well, that last bit's mucked up my theory.
What theory?
Well, I thought that maybe light things floated and heavy things sank. But that boat floats and it's mega heavy.
Well, let's look up boat building then. See if that helps. Right, that's probably it. Designing boats.
Designs for new boats are tested before they are built. Models are made from the designs and then put in special water tanks. The tanks allow scientists to test how the boats will behave when they are at sea.
That's what you need, XP. Tanks.
I'll pay a visit. Do you want to come?
I can't. I've got to finish off this lifestyle project thing. I mean, I should have done it ages ago.
Okay. See you later. Disconnecting. Express -32. Oh, Sarah.
Yes?
Tanks.
Sometimes I wished I kept my mouth shut when he asked me what jokes were. Still, at least he's not doing an inquiry about them.
Scan to identify. Audio on.
This is a boat testing laboratory. This is David. He is a boat designer.
I want to find out why my cork floated, but my plasticine sank.
Why do you think that was?
Well, I thought it was because my cork is light and my plasticine is heavy, but that can't be true, because large boats float and they're mega heavy.
Well, that's true. But let's just have a look at the cork and a piece of plasticine the same size. The cork floats because it's light for its size, whilst the plasticine sinks because it's heavy for its size.
Ah, so the plasticine will never float.
Well, that's not so. It can float if you change its shape.
Oh, right. Yes, I'll do that.
Okay. But perhaps before you go, you might like to come downstairs and see our tanks where we test models for big ships.
I'd love to. Lead on.
Thank you. So this is where we run the ship models. And we'll start it off.
What's this for, David?
This is a tank in which we can do some experiments.
Oh, great. And what are these for?
These are two tins, the biscuit tins, one of which we've crushed. Shall we see if it can float? Well, that one sinks fairly obviously. If we look at the second one, floats easily. In fact, we can even put things inside and it still floats.
Scan to confirm results.
The uncrushed biscuit tin floated because the metal it was made of was spread out. The crushed tin did not float because the same amount of metal was squashed into a lump.
Will this work for other things that are heavy for their size?
Yes, it certainly would.
Great, we can do some more experimenting.
Yes. Well, if you can do that, because I'm afraid I must dash.
Oh, really?
Nice to see you.
Oh, okay. Disconnecting, David. Bye. XP connecting Sarah. XP connecting Sarah.
Connected. Hiya.
What's heavy and you would think would sink?
This isn't one of your dreadful jokes again, is it, XP?
No. It's an inquiry.
Oh, that's all right then. Only I'm just about to start an experiment myself, you see.
Oh, well, what's the answer?
Well, I don't know. I haven't started it yet.
No. What's the answer to my question? What's heavy and you would think would sink? I can't think of an answer.
What about concrete?
That's the stuff. I'm going to build a boat of concrete. Disconnecting.
Yeah, okay. A boat? I couldn't see how XP could make a boat out of concrete. My experiments didn't seem to be heading that way at all. I've been seeing what happened when you put things in water. When I put my tennis ball into the water, it floated. I knew it had air inside it because I saw one the dog chewed, and it was all hollow. I wondered if that was a clue of some sort, so I decided to try something else with air in. I knew my sponge had air in it, and it floated right on top of the water, so I squeezed the air out of it underwater. Then, it didn't float nearly as well. Right, let's try this for Sarah's theory of floating. Things should float in my tank if they have air in them, but I should do another test to see if my theory is always true. If I can make a pocket of air inside this plasticine, then according to my theory, it should float. Oh no, it sank! Oh well, another great theory bites the dust. I decided there was only so far I could go without a bit of help, so I typed in float. F-L-O-A-T. Choose. Why things float, fishing floats, water safety, how to stay afloat. I'll choose why things float.
When you put something in water, it pushes downwards and takes up space. The water pushes upwards, almost as if it is trying to get the space back. This push is called upthrust. You'll already know about upthrust if you've ever tried to push a balloon down into water. If the upthrust, that's the force pushing up, is in balance with the weight, that's the force pushing down, then something will float.
XP really should see this. I wonder where he's got to. Oh no! He's going to build a concrete boat! He'll never do it! He doesn't know his upthrust from his ear hole! He'll drown himself! Fortunately, he left his Scandoo behind. It scanned to show me where he was, and I dashed up to rescue him. Only it turned out he didn't need rescuing at all.
Sarah, look, a concrete boat.
Oh, wowee! How much concrete went into this?
Oh, it was a heavy lump, about that size.
Has the boat got a name?
Yes, I call it Heavy Lump the Third.
Why the third?
The first two sank.
So what makes you think this one won't?
Ah, well, I asked David for some advice. David, do you think you could tell Sarah what you told me?
Yes, certainly. Sarah, what do you know about floating?
Well, I know that weight pushes down and water pushes up.
Well, that's fine. So the reason why this boat floats and that concrete doesn't is because it's much wider and it can push more water out of the way, and therefore that can provide enough of the force to keep the boat from sinking into the water.
So which way round is it then?
Well, that's the front of the boat. We normally call that the bow, and it's shaped like that in order that you can pull it through the water more easily, whereas the back of the boat is very flat here, and if you try to pull it this way, you'd find it was very difficult to keep it going straight.
So have you found a test pilot for your boat yet then?
Well, it's, someone you know, actually.
Is it?
Yes, quite well. In fact, very well. In fact.
No, XP. Not me. No way. No how. Not ever. No thank you. N-O spells no. Honestly, he could sell electric fires to snowmen, he could. So, here I am with no sails and no engine. Mind you, it does float. That's the main thing, I suppose. Actually, floating around here has given me an idea for another inquiry. I am going to try floating plasticine when I get out of here. If I get out of here. Talk about being up the creek without a paddle. I know. Scandoo. If he can work it, I can work it. Express reverse minus 3, 2, 1.
What's happening?
You are about to do some rowing, XP. That's what's happening.
Rowing? Oh, no one rows on my planet, Sarah.
My lords, ladies, and gentlemen, I, the great Swarovski, am about to perform for your amazement one of the most baffling magical mysteries ever to be seen on this or any other planet. But first, I think I better explain what I'm doing up here just as the great Swarovski instead of just plain old Sarah. It all started when XP had got hold of a ginormous balloon. And instead of it starting him off with one of his inquiries, like things usually do, he thought of something else.
How do you do that?
with a pin.
No, I mean, how did you know I was there?
I saw you in the mirror.
But I wasn't in the mirror.
Yes, you were.
No, I wasn't. I was over there.
Yes, but I can still see you in the mirror. I mean, haven't you got one?
No,
Well, how'd you brush your teeth?
with a toothbrush.
Of course you do, Space Twerp. But how do you see to brush them?
Oh, with my smart specs. I mean, what's a mirror for?
Well, it shows you things.
Amazing. That's a good topic for an investigation. I'm going to look into this.
I hope that wasn't supposed to be a joke, XP.
No. I'm going to do an inquiry into mirrors. Do you want to come?
Well, I'll give you a hand. But not if it means I have to leave the house. See, I'm waiting for my friend to phone.
Okay, I'll go and do some exploring, and you stay here and do some finding out, okay?
Okay.
XP disconnecting. Express -3, 2, 1.
So, XP set off on a mirror hunt, and I started looking up all about them. I used one every day, but I'd no idea how they worked. Mirror. Fun in Mirrorland. How mirrors work. Alice through the looking glass. Better start at the beginning, I guess.
In the dark, you can't see things. You need a light source. A lamp, a candle, or the sun before you can see anything. This is because we only see things around us when light is reflected from them into our eyes. Light from the light source travels to an object and is reflected into our eyes. This is how we see the object. Everything around us reflects light. But some shiny things, water, metal, glass, and mirrors, reflect all the light. If a surface is smooth and flat, you can see yourself clearly. But mirrors turn you around from side to side. When you hold up your left hand in a mirror, your reflection makes it seem as if you are holding up your right hand. Just like your writing looks different if you hold it up to a mirror.
Well, I sort of get it. Let's try this one. Fun in Mirrorland. Mirror mazes, something or other, mirror writing and mirror magic. Okay, mirror writing.
If you hold up your writing to a mirror, it looks different. This is because the mirror reverses all the letters. Some letters still look the same even when they are reversed. Type in your own name to see if you have any of these letters in it.
Okay. S-A-R-A-H. Choose mirror or normal. Okay, I choose mirror. Ah, neat trick. And the A and the H stay the same. I must get XP to try this one out. Okay, what shall I try next? Okay, let's try the second one down.
A kaleidoscope is a toy that makes patterns by using mirrors. You look through it and turn it round at the same time. What you see are pieces of colored paper reflected in 3 different mirrors. The mirrors face each other in a triangle. Their reflections of the colored paper make a pattern. You can easily make a simple homemade kaleidoscope for yourself.
Something else I can show XP. I wonder what else there is. Aha! Mirror magic.
Magic mirrors sometimes appear in fairy tales, but in real life they can only reflect what is in front of them. This fact has still been put to many amazing uses. Before each Olympic Games, people in Greece, where the first games were held, use a mirror to concentrate the rays of the sun together to light a torch. This torch is then carried to the place in the world where the games are being held. In sunny countries, you can send signals to people who are far away by using mirrors. This heliograph bounces flashes of sunlight to a person many miles away. In the circle, you can see that person sending a message back. Magicians sometimes use mirrors to make their tricks seem like magic.
Right, XP. You wanted to play tricks. Let's see if I can play one. A real one.
Aha! Activate scan do. Investigating mirrors. Scan to record.
Activate smart specs. Audio on.
Activated.
Access scan do.
Scan do accessed.
Question: how many reflections have I scanned?
You have scanned 10 reflections.
Question: how many mirrors have I seen?
You have seen 4 mirrors. The other 6 were shiny surfaces.
How many of the reflections made me look normal, and how many of them made me look all funny?
5 reflections made you look normal, and 5 made you look funny.
That's not what I was expecting. I thought it would be mirrors that made me look normal, and shiny surfaces that made me look all funny.
Not correct. Some mirrors did not reflect you normally. Suggest you examine mirrors only.
Show the mirrors that made me look normal.
Showing.
Show the mirrors that made me look all sort of funny.
Showing.
Question: do flat mirrors make me look normal, and ones with curves in them make me look all funny?
According to available scans, this is correct.
Prompt to assist.
Assisting. Suggest you test theory with more scans.
Right. Let's find some more flat mirrors and some more curvy ones.
XP tested his theory and found it was right. He saw ordinary reflections in flat mirrors and funny reflections in curved ones. Meanwhile, I had found myself a magician who's going to help me with a trick.
Come in.
Hi, are you Mike?
That's right.
So you do all the magic and stuff?
Sort of. I do magic which can be explained by science and then get people to try and work out the science behind it. But I can do real magic too. I'll show you a trick. Here's a piece of rope. Two ends there. And make a loop in it, like that. And now I'm going to cut the rope in half. There we are. Now let's join it together. There we are. That doesn't seem very magic, does it? Okay, let's use some magic on it. Get my wand. Rub it over the rope like that. Open it out. And the knot's disappeared.
So have you got any tricks to do with mirrors?
Yes, I've got a box over here which uses mirrors which look like magic. There we are.
So that's why I'm up here dressed like this. Anyway, my trick's all ready now. Let's see if it works on XP. My lords, ladies, and special visitor from another planet. That's you, XP. I, the great Swarovski, will now demonstrate the amazing magical vanishing cabinet. But first, I need a volunteer from the audience. You, sir, if you care to step up on stage. Now, I need to borrow something. Using my amazing powers of telepathy, something tells me that in your pocket you have a packet of crisps.
Absolutely right, Sarah.
Thank you. Sir, would you please look into the magic square? Keep looking at it as I take your bag of crisps and right before your very eyes, make it disappear. Do you have another packet?
Yes, sir.
Thank you. Look very closely as I take your bag of crisps and abracadabra, make it disappear. Thank you. What do you think, XP?
Wow, well, that was amazing. You must have enormous magical powers. I've known you all this time and you've never once let on. On my planet, only the almighty Weeble has such awesome power.
It was a trick, XP.
But not even his awesome... What do you mean a trick?
It was a trick. It was all done with mirrors.
With mirrors? I don't believe you. You mean mirrors at my crisps? No. You're pushing my foot.
I think you mean pulling your leg, and I'm not. Honestly, it was a trick and all done with mirrors. Should we tell him about it?
Yeah, why don't we? Well, it works like this. The crisps are in here, in a secret compartment, which you can't see because there's a mirror running from this corner here down to the corner at the back. The mirror gives a reflection of this half of the box in the mirror so that it looks like a whole box.
What about the ball floating in the air?
That's actually half a ball, which is stuck to the mirror so that it looks like a whole ball.
Extraordinary. Activate smart specs. Scan to confirm.
Confirming. The box is divided in half by a tilted mirror. Half a ball stuck onto the mirror looks like a whole ball floating in mid-air. What looks like the back of the box is really the reflection of the front of the box. Behind the mirror is a hidden compartment where your crisp packets went.
Extraordinary.
So, you see, XP, it was all a trick, just using mirrors. Anyway, what did you find out?
Well, Sarah, I learnt that from flat mirrors, you get normal reflections, and funny reflections from curved mirrors. And it's the same with shiny surfaces. Flat for normal, funny for curved. What about you?
Well, I've got this really good mirror writing for you to try out, and a kaleidoscope. Are there any other good ideas?
Yes, you could get a couple of mirrors and see if you can see over high walls using both of them.
Well, now I shall show you two a trick, if you would like to take a seat. The great Expeditious will present for you, lady and gentlemen, Sawing the Magician in Half. Stop that. Sarah, I'm in a bit of trouble. I've forgotten how to put myself together again. Come back, Sarah. Oh.